Math 098, Chapter 3, Section 5, and we'll be doing absolute value inequalities. So the premise in this problem is it's a little bit more complicated than just saying that we could be positive or negative. Because here's the reality, is what's inside the absolute value has its limits. Because if you just said that x could be less than 5, okay, you definitely are finding true answers for x. And I'll just make a table real quick. Like if you were to do x and then absolute value of x. So like 4 works because the absolute value of 4 is 4 and that's less than 5. You know, let me skip a few numbers. Like 1 still works. Absolute value of 1 is still 1. But what about when you get to negative values like negative 2? Okay, so negative 2 works because the absolute value of negative 2 is 2, which is less than 5. But what about when you get to negative 6? Negative 6 is less than 5, right? So negative 6 satisfies this statement, but the absolute value of negative 6 is positive 6, so it doesn't satisfy this top equation. So this is a counterexample. So we need a better answer. And that better answer is to say that x could be less than 5 and x must be bigger than negative 5, because if you say x is bigger than negative 5, we're no longer talking about negative 6. And you probably guessed it, we're going to go to Desmos to see this. No, we don't need Desmos because absolute value is an easy graph. Absolute value looks like this. It's a V-shaped curve. And then let's just give you a value of being 5. So this horizontal line is y equals 5. So in order for the absolute value to be less than, it needs to be below that curve. Well, if we're looking at the part that's below the curve, we're talking about from negative 5 to 0, but then also from 0 to 5, and that's where we get into this statement. So think about that as we move to the next. I think they're more difficult problems. So when you get a statement like this, where it says less than, absolute value is less than, you want to make an and statement. Because what you want to do is you want to say that m minus 6 is less than 2 and m minus 6 must be greater than negative 2. Now some teachers explain this a little bit differently than I do. Because what they do is they say, well, if you put a negative in front of this, m minus 6 is less than 2, and then you divide that negative over, what happens when you divide by a negative? It switches that inequality. Oh, whoops, I wrote the wrong number. I was supposed to say negative 1. I don't do that because I just like memorizing that as you do the other problem, you flip the inequality. Now it's an and because of this inequality. So now you can just solve it. Let me go back to my other color. That we could add 6 over, add 6 over. So what we want is values for m that are smaller than 8 and greater than negative 2 plus 6 is 4. So now I'm going to go to Desmos to sort of talk you through this problem. Desmos. Now instead of using m, I'm going to use x. I hope you're okay with that. X minus 6, absolute value, and 2. Y equals 2. So as I zoom in and look at, we want where my absolute value equation is less than that horizontal line, and you can see at x equals 4, it's actually on it, and then x equals 8, it's on it. It might actually make it helpful to write this as less than, so you can actually see that we want the shaded region below that. That's what we want. So that's why we want values bigger than 4 but smaller than 8. In interval notation, since we practiced that before, you could write this in interval notation as values for m that are bigger than 4 but smaller than 8. So as we look at the next problem, I'll switch colors. Remember earlier in the previous video, we isolate the absolute value. So you want to do that here as well. So you do that by subtracting 1 to the right side. So you get 9. So this is a less than, so it's an AND statement. So what I'm saying is 5x plus 1 needs to be less than or equal to 9, and 5x plus 1 must be greater than or equal to negative 9. So now it's the same two-step process where you subtract 1 over and divide by 5, so we're looking at 8/5. You can change that to a decimal if you want. I just don't want. So x must be greater than or equal to negative 2. So without looking at a graph, because we don't need a graph, this answer in interval notation would be values for x that are bigger than negative 2 but smaller than 8/5. Just like that. Okay, but on your own, go ahead and double check that that answer makes sense using Desmos or your graphing calculator. Now here's another tricky thing, and think about this, is sometimes we get an answer that doesn't make any sense. So before working through this problem, think abstractly for a second. This value, absolute value, must be positive. This value is a negative. Will a positive number ever be bigger than a negative number? No, no solution. Don't do math if you are a good critical thinker. Okay, don't waste your time. Now here, if you look at this one, this is actually a problem where your answer is a single number, because the only way for this absolute value to be less than or equal to 0 is if it simply equals 0. Because this value will always be positive or 0, so you might get a numerical answer. The way I would do this, if you want my opinion, is I'd multiply both sides by 5 first to cancel out the 5s. Well, 0 times 5 is just 0. Then divide both sides by 3. Cancel out that 3. Well, 0 divided by 3 is still 0. So you're just looking at x minus 2 is equal to 0. So x must equal 2. Notice this is not an interval. It's just a numerical value. It's the only answer that works. It's not very often, but this does happen sometimes. Oops. And then what we're looking at with the next one is a greater than symbol. So this is a lot different. Let's go to Desmos right away. And let's look at it's x plus 4. I know it says y, but I'm going to write it with x. So this graph is moved this way. But now we're looking for values that are greater than or equal to 6. So as I zoom out, I think you can tell we want an OR statement now, because we want the graph to be to the left of negative 10 or to the right of positive 2. So let's algebraically work that out. So when you see a greater than, it becomes an OR statement. Absolute value is greater than is less than or equal to negative 6. So as you subtract 4 over, I think it makes perfect sense that 6 minus 4 is 2. Or, as you subtract 4 over, negative 6 minus 4 is negative 10. And we already graphed it using Desmos. I do want to point out on interval notation, you would write negative infinity to negative 10 with a bracket, union, which literally means OR, to infinity. And then this next one is very similar in the sense that you want to isolate the absolute value. Well, when you do that, now be a good critical thinker, because when you subtract 5 over, you get negative 2. And again, be a good critical thinker. This is a positive is greater than a negative. This is always true. So don't work through a problem when it's obvious that the answer for x is all real numbers, or in interval notation, negative infinity to infinity. Again, pause the video, really soak this in. Make sure you understand before attempting the problems on your own. And then this last one wants you to use a graphical approach to do this problem. So we'll go back to Desmos. I'm sure you're tired of hearing me say that, but we have x over 2. What we have? Minus 3, minus 3. You do have to write it in this order, by the way. And you got to find where your graph hits the x-axis. Because if you are looking for where the function is greater than 0, well, the equation y equals 0 is what we are, and you can even write greater than 0, and you'll see that we're looking for the x-axis and where it's above the x-axis. Yeah, so as I'm looking at this is definitely an OR statement. We want values for x that are less than 0, but then bigger than 12. And that's in the shaded region for what we're looking for. So without doing any algebra, you can use a graph to see x is less than 0 or x is greater than 12. And in interval notation, because I do want you to practice that, union or 12 to infinity. I think we've covered enough that you should be successful on this homework. Due in a couple days or tomorrow. I don't remember how I would set it up.